everyone, in this video I'm going to talk about modeling with quadratics. In the mathematics, we usually use a model to describe a real-life situation. I often heard the students ask me why I should learn math. Math is not useful, math is so hard and I don't want to learn that. But actually, we can use mathematics in the real life. So the model we can use can explore the real-life patterns and predict what is going to happen next. So in the exam, the questions often related to the real-life situation. When we're doing such questions, one thing we need to be aware of that is a precondition. For example, if the question relevant to the time, we cannot have the negative number of the time. We only have the positive and the zero, right? So 0 seconds, 1 second, 2 seconds. We cannot have the minus 1 seconds. So we need to consider the precondition of the question. Now let's do questions for an example. So for this question, a ball is thrown over level ground from the top of a tower. The height in meters, be aware of the unit, in meters of the ball above the ground after t seconds, is modeled by the function ht equals to 14.5 plus 16.25t minus 5.8t squared. We find that it is quadratic. And a t greater than and equal to 0. Here, that is a precondition. Now, for the part B, it asks you to interpret the meaning of the constant term 14.5 in the model. Well, when we think about that, how can we just left only 14.5 in this function? That is when t equals to 0. So t equals to 0, that is h0 equals to 14.5. So what happened when t equals to 0 in the real life condition, in the real life situation, for this question? That is, the ball is on the top of the tower. So it means it is the height of the tower. It implies the height of tower is 14.5 meter. Don't forget to write the unit. Now, for the part B, the question asks you, after how many seconds does the ball hit the ground? Well, I think we can draw a graph or draw a diagram to see what happened for this ball, to see what happened to this ball. Then we can draw it. We can draw here it's a level and here is the height. We can see this is the height. So we have the tower over here. This is tower that is 14.5, the top of that. And the ball is thrown over level ground from the top of the tower. So we threw of that to it hit the ground, right? Do you think it is really similar to the quadratic graph? That's it if I fill this part. Have you seen this is a perfect quadratic graph of that? So what this question actually asks is to ask you the root of this function, right? Because when it hits the ground, it seems like it hits the x-axis, right? So when the graph crosses x-axis, it means you need to find the root of the function. That is ht equals to 0, right? So we need to find the values of t. That implies 14.5 plus 16.25t minus 5.8t squared equals to 0. Then what we need to do, we can use the quadratic formula. What is quadratic formula? I have taught before. That is t equals to minus b plus minus square root of b squared minus 4ac over 2a. In here, to be aware of that, don't read wrong a, b, c. So a is let me use a different color. A equals to minus 5.8 because remember a is a coefficient of the t squared, or maybe x squared. In here is just the t squared. And b equals to 16.25. C equals to 14.5. And we substitute these numbers into the formula. We write that equals to minus 16.25 plus minus square root of 16.25 squared minus 4 times minus 5.8 times 14.5 and over 2a. Right? Now it's our time to use a calculator. Yeah, we need to calculate the square roots of what number? Wait a minute. Not 2a, I forgot to substitute. So 2 times minus 5.8. And then use the calculator. We have minus 16.25 plus minus. Let me use the calculator. So that is 16.25 squared. So minus times minus, that is plus. So plus 4 times 5.8 times 14.5. What do we have? We have 600.46 over 2 times minus 5.8. That is minus 11.6. And then we have two roots. The first one, so t1 equals to minus 16.25 minus square root of 600.46 over minus 11.6. So we use a calculator again. So minus 16.25 minus square root of 600.46 over minus 11.6. What we have? We have 3.51 to the 3 significant figures. And another root, that t2 equals to minus 16.25 plus square root of 600.46 over minus 11.6. What we have? Calculator plus, that is minus 0.71. So 712. Yeah, to 3 significant figures. We usually write up to the 3 significant figures. In other case, if the questions ask you to write two significant figures, then you should write that. So we usually up to the 3 significant figures. Do we stop here? I don't think so. what is a precondition for this question? That is t greater than or equal to 0. So t greater than equal to 0. Since t, thus what we get, t equals to 3.51 seconds. Right? So 2, 3 significant figures. Yeah, so that is the answer. So we finish this part of the question. Now move on to the part C. So what that the part C said? Write ht in the form a minus b times t minus c, square of that, and find the values of a, b, and c. Do you think this is familiar? What is that? It is completing the square. So what we need to do, we need to do the completing the square of the function. We have ht equals to, let's see, 14.5 plus 16.25t. Yeah, we don't write wrong. Minus 5.8t squared. And we do the completing square. Well, I like to put the coefficient of a in front, so we rearrange that at minus 5.8t squared plus 16.25t plus 14.5. What do we have? We should take out the minus 5.8, so times t squared. So 16.25 divided by minus 5.8. What we have? We have minus, well, I think this time we need to write the numerator and denominator, so minus 325 over 116. Well, that is a terrible number. Sorry for that, it's a quite terrible one. And then we plus 14.5. And then we do the completing square, that's minus 5.8 times t squared minus 30. Well, that's quite long. I don't read that. I hate this number. Plus, so we divide by 2. That is 325. Divide 2, that is 116 times 2. So it's 232 square of that and minus that. Wow. Huge number. Seems huge. And then plus 14.5. Let's move this away. I need more space. So what we have equals to minus 5.8 times t minus 325 over 232. Square of that. And minus 325, 232, square of that. Yeah, plus 14.5, and take the square at 325 over 232, square of that out. That times minus 5.8. So we have minus 5.8 times t minus 325 over 232 squared. So that should be plus what we have. So use a calculator, we get 325 over 232 squared of that times 5.8. We have Sorry. Wait a minute. Let me spell the wrong. I typed the wrong number. So that is 11.38. That's right, 11.4. So to the three significant figures. And then plus 14.5. What do we have? We have minus 5.8 t minus 325,232 square of that plus 14.5, that is 25.9 to the three significant figures. Sorry for the terrible number, but in the exam question, it should be the exact number. You don't need to up to the three significant figures. Sorry for this inconvenience for this question that I made it. So what we have A equals to, so A is a constant one, that is A equals to 5.9, and B equals to 5.8, and C equals to 325 over 232. Right? Okay, now for the part D, what it asks you to use your answer to part C or otherwise. So I have told before that when you see this question, we can use the answer from the previous question. Find the maximum height of the ball above the ground and the time at which this maximum height is reached. So maximum height and the time at which this maximum height is reached. So in other words, it asks you about the turning point. Right? When you see the maximum or the minimum of the quadratic curve, it always asks you about the turning point. So maximum, we can use the completing the square of the function. So complete square function, that is ht equals to minus 5.8 times t minus 325 over 232 square of that plus 25.9. So the maximum is when t minus 325 over 232 equals to 0. So what we have t equals to 325 over 232, that equals to, let me check, so 325 over 232, that is 1.40, that is to three significant figures. And the height, so h 325 over 232 equals to 25.9. So that is the answer we need. So the maximum height is 25.9 meters. And the time is at 1.40 seconds. Right? Now we have done this question. Let us quickly see the whole process. So when you do the questions relative to the real life situations, you need to first consider the precondition to be aware of that, and interpret the meaning of the constant term. So the constant term is when t equals to 0. So what we left is h0. So it is a starting point of this real life situation. After how many seconds that the ball hits the ground, which means you need to find the roots. In this question, you need to find the roots of the function. It is better to draw a graph or diagram when you're doing your exam or doing the question. It is really useful. It shows clearly how the questions work and what the question is talk about. Yeah. And then do that. When you solve that, you have two roots probably. And for the two roots, you need to remember that the precondition over here. So you can only have one root. And in here, in other words, you need to do the completing square. And then when you see the maximum or minimum height, or the time at which maximum height is talking about the turning point. So it's really easy that when you interpret your questions into the mathematical way, that is like the turning point of the roots of the function. So you can just follow the knowledge and the solution process that I have taught in the previous videos to solve this real life situation question. Yeah, the question of the real life situation. Now we finished this lesson. Hope you enjoy watching this. Thank you.